Today we're doing graphs. So we've done all types of representations of functions and relationships. And just to remind us, that would be the flow diagram, the table, the algebraic equation, and today we're doing graphs, which is the last of the 4 types of representations of functions. So to start off the lesson, I'm just going to ask you guys to help me find the coordinates for this graph that, well, it's not a graph, the coordinates for the points that I'm showing right now. Okay, so we're just going to remind ourselves how we find coordinates. We're just going to go from A to E and let's get going. I'm expecting full participation from us here. We did this before, so you guys should be at least semi-confident in doing this, right? You guys should be. Seth is very confident because Seth has already told me what A is. Thank you, guys. Thank you. Okay, let's get started. So as Seth said, the coordinates of A is +3 and +4. Okay. Nice, Seth. I'm glad that you realized your mistake before I even had to point it out. You did it yourself. Okay. Can you guys tell me what are the coordinates of point B? Point B, here's point B over here. What are my coordinates for point B? If we start in the middle of the x-axis, we go 1, 2, 3, -3. Okay. Nice, wedge. So it's -3. And if we start in the middle again, we go 1, 2, up. So it's +2 for y. Now let's look at the coordinates of point C. What are my coordinates for point C? Remember, we always start in the middle and then you count up to the line where your point is. So it's -1, -2. So I've already given you half of my coordinates. Hello, Logan. Hello, hello to everyone who joined after I greeted. Nice, nice, guys. So it's -2 and -4 and D. My coordinates for point D, which is all the way on the side over here. I like that you guys are writing these coordinates correctly with my brackets and my semicolon and in the right order, which is X, Y. So let's write the one for D. Nice, Nhlamulo and Linomta and Seth. That would be 6 and -3. And finally, my points for E, which is smack in the middle of this whole thing. My final point, which is E. It's right in the middle. Which means we have not moved up or down and we have not moved left or right. Nice, Seth. That point is 0, 0. Also called the origin. Okay, it's where everything starts, the origin. Okay, so we have reminded ourselves of how to find coordinates. And as promised in our previous lesson, I said we were going to finish this by finding the equation of this graph. Okay, so let's get started by finding my coordinates again. And I actually realized a mistake in the last time we did this. So I'm going to show you guys now what that mistake was. A, B, C, and D. Okay, what are my coordinates for point A? We are finding the equation of this graph now. This is the last graph we did on Tuesday, and I said we would start here because we were not done with this question. So what are my coordinates for point A? Let me zoom in a little bit so you can see. There we go. Point A coordinates. Nice, Nhlamulo. -1 and -8. Okay. So point A is -1, -8. Let's look at point B, which is on my y-axis. If a point is on any axis, one of them will be 0. Which one is it in this case? That is true. It is x. So then my point is 0 and... Nice. 0 and -3. Okay. Let's go up to point C. We're back on the graph now. We're not on an axis anymore. Point C. What is my point for point C? 1 and not 3. Look carefully. 1 and 2. Nice. 1 and 2. And my final point, which is point D, which is all the way up there. What's happening with point D? Point D is 2 and 7. Nice, Buhlali. Okay, so let me rewrite these in the point X and Y as we would in a table, where we have my input at the top. Input, apparently I don't know how to spell. Input and output. For my first one, my input would be -1 because that is the X coordinate. What is my input for the second one? That is 0. My third one, 1. And the final one, 2. Output for point 1, or point A rather, -8. Point B, nice, -3. Point C, 2. And point D, 7. So once again, actually not once again, let's look at what my multiplier is here. What is my multiplier here? I'm going from -8 to -3, -3 to 2, and 2 to 5. Plus 5. Do you guys remember what we said the multiplier was in the previous lesson? -5. Does anybody realize why we had a multiplier of -5? Anyone realize why our multiplier was incorrect? +5 and -5 are definitely not the same. So does anybody realize why our multiplier was wrong? It's because our inputs were in the wrong order. Remember in the previous lesson, we started from 2. So it was 2, 1, 0, -1. We were going backwards. So your input always has to be in the correct order before you decide what your multiplier is. Okay, so make a note somewhere of that. That my inputs must be in the correct order. Okay. So it was going the opposite way. That's why we ended up with a -5 for our multiplier. Okay, now we have our multiplier. Let's start with the first one, and I didn't even write it. +5. First one, I'm going to say -1 times 5. What's -1 times 5? -1 times 5. That's -5. But is that the output that we're looking for here? No, we're looking for -8. So how am I going to get from -5 to -8? We're going to subtract 3, and that will give us -8. Now remember, you have to try it with another point just to verify it and see that it's correct. So I'm going to try it with the last one. 2 times 5. What's 2 times 5? That is 10. And if I subtract 3, I'm going to get 7. Is 7 the output we are looking for my input of 2? Yes, it is. So what is the actual formula for this graph here? The actual formula for my graph is the correct formula. Now that we have the correct multiplier, it's going to be nice, or 5x, 5 times x minus 3. Okay, so the big takeaway here is that my input must be in the correct order so that we get our correct multiplier. Now, the next one says, draw the graph of 5 minus x for the values from -3 to 3. Luckily, they've given us a table already. So if you don't have a table, that would be a first step, right? You would have to firstly draw a table so that you can find your coordinates. Now let's start with the first one. Y equals 5 minus -3. So the first one says y equals 5 minus -3. What are those two negatives going to become? I have a negative in between, and those two negatives are going to be a positive. Okay, so I'm going to say this is equal to 5 plus 3. So then my output will be what? 8. So the first point for an input of -3, I have an output of 8. Let's do the second one. Y equals 5 minus -2. Once again, I have my plus. It's going to give me a negative, excuse me, which is going to give me a positive. And this is equal to 5 plus 2, which is 7. Okay, next one, y equals 5 minus -1. What is my output for this? We should already be able to see it. It's going to give me 5 plus 1, which is 6. And for the next one, y equals 5 minus 0. What's 5 minus 0? It's just 5. Okay, we're almost there. We have 3 more actually. Y is equal to 5 minus 1. And 5 minus 1 is going to give us 4. Y equals 5 minus 2. That is 3. Thank you, Logan. And the final one, y equals to 5 minus 3. And what is my final output? That is 2. Now let me fill in my table here. I've been neglecting my table a little bit. This is 6, 5, 4, 3, and 2. Now we have to go and plot this graph using the points that we have just found here. So I'm going to zoom out so that I can see the points that I'm plotting. Now, if you look here, guys, if you are in a test and you are writing a graph, well, drawing a graph, you do not have to draw the whole Cartesian plane because the whole bottom of this will be wasted, right? If you look at all your outputs, are there any negative numbers for the outputs that you have? Do we have any negative numbers in my output? No. Which means the bottom of the y-axis would be unnecessary because there won't be a point at the bottom of the y-axis. All of them are above the y-axis. Do you understand why it looks like this? There wouldn't be a need for us to, although I would draw, firstly, I would draw an arrow there and I would draw a little piece here to show that it technically goes on and on and on. But for this specific graph, we do not need to draw the negative part of my axis. Now let's point this quickly. First one says for -3, we're going to plot it at 8. So it goes there. -2 is 7. -1, 6. 0 at 5. 1 at 4, and 2 at 3, and 3 at 2. Okay, so I'm not the best artist here, so I'm just going to use my line to draw this graph. There we go. Okay, now when you draw this graph in a test, what will you use to make sure that this is a proper line? You cannot freehand it and wing it. You have to draw a proper straight line using a ruler, please. Okay, and if you draw this line and one of your points are out, let's say there's a point over there. What do you do in that case? What do you do if one of your points, you see a trend, but then suddenly one of them is all the way over there? And then, okay, Seth says reposition, Logan says erase. You don't do either of those. You check your answers. Okay. If one point is out there, then probably something went wrong with your data, unless it's given, unless your teacher gave you those coordinates. If you are the one that calculated it, you must go back and check. Why is only 1 point out of this? How is it possible that one of my points is out of this line? Okay, so this is a linear or straight line graph. So this is linear. In other words, straight line graph. Okay. Would you guys say this graph is increasing or decreasing? Would you say this is an increasing or a decreasing graph? That is correct. This is a decreasing graph. And how do we know that? Because my y values are going less and less and less and less. We started at 8, 7, 6, 5, 4, 3, 2. If this graph kept going, it would keep going less and less and less and less. It's a decreasing graph. All right. Let me fix this quickly. There we go. Okay. This one said, well, it says copy and complete, but we already have this table. For the relationship y is equal to x squared. That's a little bit different from what we've been doing so far. So let's check. We have a lot of inputs here, so let's get going. First one, y equals -5 all squared. What's -5 all squared? Remember, it's the same as -5 times -5. And 2 negatives will give you a, what will 2 negatives give me? A positive. So it's positive 25. That's my first input or output, okay? Next one says y equals -4 squared. What's -4 squared? Once again, it's 2 negatives that are squared. So -4 squared, that is 16, beautiful. Next one, y equals -3 squared. I'm going to keep writing this so you understand why the answer is positive. This is 9. Next, y equals -2 squared. Nice, we're getting it much faster, which is 4. Of course, I'm going to write 3 equals. There we go. Okay, where did I stop? -2. Y equals -1 squared. That's -1 times -1, which is +1. And y equals 0 squared. We're into the positive category almost now. Territory, not category. 0 squared is, what's anything times 0? It's just 0. Okay, y equals 1 squared. Y equals 1 squared will give us a 1. What do you guys see is happening here? Y equals 2 squared. Look at the past answers that we've gotten and check what is happening here. What do you guys see? Do you guys see anything, or should I just write the rest of them? Y equals 3 squared. 3 squared is? I see, I see. You guys are noticing some stuff. 4 squared. Y equals 4 squared is 16. And finally, y equals 5 squared. 25. Now, I'm going to fill these in on the table so we can see what I'm trying to show you here properly. Let's see. Okay, so here I have 25, 16, 9, 4, 1, and 0. And then I start going back up. But look at these results now for the other side. They're like a mirror image. Do you see that? So straight after 0, you have 1s on both sides. And then 2 spaces after 0, you have 4s on both sides. Now, let me ask you, do you guys think this will be a straight line graph? Do you think this will be a straight line graph? No, this is not a linear graph. And what could have told us that in the formula? This formula would have told us that this is not a linear graph. What is it about that formula that would have told us that? It says y equals x squared. What do you mean, LM? What about this formula would have told us that this is not a linear graph? It is the square. As soon as your x or your input is squared, you no longer have a linear graph. Okay? So as soon as you see, you don't even have to draw the graph. As soon as you see y equals x cubed or y equals x squared plus 1, you no longer have a linear graph. Okay, but let's plot it and see what it looks like. Does anybody know what it's going to look like? So for 0, we are at 0, right? For 1, we are at 1. So 1 and -1 have the same result. Okay, 2, we are at 4, so we're there. There. 3, we are at 9, so we're there. 4 is all the way up there at 16. Oop. My eyes are starting to play games with me. 5 is at 25. 6, okay, we didn't go to 6. Okay, I see you guys say it's a V, but it's actually more of a U. Okay, so you do not take your ruler and join these lines because they will not make a straight line. Let me show you. Let me insert a line and show you that this is not, in fact, a straight line graph. Do you guys see that? If it was a V, then all my points would be right on that line. Right? Whoop. If it was a V, then all my points would be on that line. So this is more of a U. This is a curved graph. So you're not allowed to take your ruler. Now I'm going to struggle with drawing this. I just know. Let us see how this is going to happen. Hello, it's okay. Welcome, welcome. Okay, this is going to be a struggle, so you guys better not judge me. Okay, just, nope. I promise you guys I draw this much better on paper. But it goes something like, okay. Let's try and like move this thing here. Seth is laughing at me. Seth, this is not funny. Ooh. Okay, I got most of my points on it. Just imagine all of my points are on it for now, okay? Just imagine. Just use your imagination here, okay? Let's see the next one. This one is really going to charm me because it's on the left-hand side. But let's see. No, I was doing so well. We can't spend half the lesson with me drawing this graph. Okay. Now my pen won't even draw. Whatever. You know what? You guys can use your imagination. It's supposed to be a U. I'm much better on paper and on the board, guys. My graphs look beautiful. Okay. Okay, I'm gonna take that. I'm gonna take that. The point is it's not a straight line, okay? Because if you insert a straight line here, it will not touch all of these points. It is more of a U shape. So this is called a quadratic graph, and you will probably, we'll deal more with this when we're doing graphs later on in the year. Oh, okay. What a difficult, guys, what a difficult. Now, based on what I said about linear graphs, okay, before we even plot the points, do you guys think this is a linear graph? Before I even plot the points, do you guys think this will be a linear graph? We have a yes and a no and a no. Guys, what did I say shows you that is a linear graph? Let's see. Let's look at the formula. Y is equal to 15 plus x. Not quite if it's straight. I just said something about the x. I said something about x. Right? I said this wasn't a linear graph because it had a square. Right? Does this graph have anything, any exponents on the x? Does this graph have any exponents on the x? Look at my formula here. No. So is it a linear graph? Yes, it is. This will in fact be a linear graph because there is no exponent on x. So when there is an exponent, then you already know that this is not a straight line graph. It's going to curve at some point. All right. Now let's fill this in. Okay, this is a very easy formula to calculate. Y is equal to 15 times x. First input, y is equal to, why am I writing in blue? First one is y is equal to negative 15. Nope, 15. The 15 is first. 15 plus negative 15. There we go. Now, what does this positive negative give us? A positive and a negative will turn into a negative. So this is 15 minus 15. So then my output is 0. 0. There we go. Okay, next one. Y is equal to 15 plus negative 10. Once again, we have that positive negative in the middle, which will give me a negative. So this is 15 minus 10. And my output is 5. Okay. Third one, y is equal to 15 plus negative 5, which will give me 15 plus a negative 5 will give me what? 10. That is true. So let me write this here. 10. Y equals 15 plus 0. That's just 15. The next one, y is equal to 15 minus 5. That is 10. Y is equal to, it's plus. It's plus. We're supposed to be adding, guys. Supposed to be adding. Because I was thinking, when did this become now a quadratic function? It isn't. 15 plus 5. It's plus. Our formula said plus. There we go. 20. This looks much better. Y equals, what did I skip? I skipped something. So I said 15 plus 0, 15 plus 5, 15 plus 10, that's 25. And the last one was 15 plus 15, which will give me 30. Okay, so it's 10, 15, 20, 25, and 30. So before we even plotted this, we knew that it would be a straight line graph. Okay, so negative 15 here on the x-axis is 0. So then my point is on the axis. Okay, negative 10 is at 5. Negative 5 is at 10, 15, 20, 25, and 30. Okay, luckily I don't have to draw this one. Luckily, I do not have to draw this one. I can just use the line and join my points. And that's my graph. Now, is this an increasing or a decreasing graph? Increasing. Does anybody notice how we can use my formula once again? Okay, I know this is part of graphs, but does anyone know how I can use my formula to determine whether it's an increasing or decreasing graph? Let me remind you again, this was my decreasing graph, okay? My formula was 5 minus x. This one is 15 plus x. So my decreasing graph was 5 minus x. And my increasing graph is 15 minus x plus x. So how do you guys think we can tell just from the formula whether it's going to be an increasing or decreasing graph? Anyone have an idea? Nice. If you look at x, here it is positive. If the number before your x is positive, it's an increasing graph. And if the number before your x is a negative, it will be a decreasing graph. So let me put some few examples here. If I say y equals 2x plus 1, is this an increasing or a decreasing graph? Y equals 2x plus 1. Will this be increasing or decreasing? Exactly. Why is it increasing, Buhlali? This is an increase because the number before or the coefficient of x is 2, positive 2. Okay, so it's positive, so it has to be an increasing graph. So if I say y equals negative 4x minus 3, okay, plus 3, will this be an increasing or decreasing graph? Negative 4x plus 3. This is decreasing. Nice, guys. Remember, Buhlali, we're looking at the number before x. So this guy, and this is a negative 4. So we know that this will be an decreasing graph. All right. And once again, y equals x squared and y equals 2x. Which one is linear and which is non-linear? Let's see if we can remember this. Which one would be, is x squared linear or non-linear? And is 2x linear or non-linear? Let's start with x squared. X squared, linear or not linear? How do you know that, Buhlali? And the 2x is? That would be linear. Because, once again, this time we look at my exponents. There was no exponents there, so this is a linear graph. Okay, I haven't had a thumbs up, thumbs down. So far on what we've done, let's have a thumbs up, thumbs down. Are we all following? Nice, guys. Nice, nice. I like it. Okay. Now we're going to find the points on this graph, and then we're going to find the equation of this graph. Luckily, we already have a nice table over there to fit in our points. So we only want 1, 2, 3, 4, 5 points, not all of them on the graph, because that's going to take us forever. So let's look at -2. Is that -2 our input or our output? This one. Is it our input or output? That's my input. So am I going to look for that -2 on my X or my Y axis? I'm going to look for it on my X axis. So here it is over here. There. So what is the Y coordinate for the input of -2? My Y coordinate will be nice, -3, because it is over here. Next one, -1. We said the top row is my input. So we're looking for it on our X axis, which means it's this one here. What is my Y value? Nice slogan, -1. Okay. For 0, they were very nice because they put it in brackets for us. For an input of 0, what would my output be? For an input of 0, they've put it in nice brackets for us. My output would be 1. For my input of 1, my output is 3. It's this point over here. And finally, for my input of 2, my output is nice, guys. My output is 5, which is over there. Now, let's find the equation of this graph. Let's look at my outputs. From -3 to -1, 1, 3, and 5. What is happening with my outputs? -3, -1, 1, 3, and 5. We are adding 2. So then 2 will become my what? Multiplier. Okay, this is 2. All right. So start with the first one. I'm going to say 2 times -2. What is 2 times -2? -4. And how am I going to get to the output we want, which is -3? How will I get to -3 from -4? Nice, Iminati. I'm going to add 1, and that'll give me my output that I want, which is -3. Now let's try it with something else. Let's try it with 1. 2 times 1. 2 times 1. You guys are brilliant. I love it. 2 times 1 is, that's 2. And if I add 1, I get 3. Is 3 the outputs that I'm looking for? Is 3 the outputs that I'm looking for? Yes, it is, because look here, for an input of 1, I have an output of 3. So then what is the formula for this graph, for the equation? What is the equation of my graph? Nice. Y is equal to 2x plus 1. Nice, guys. Beautiful. Okay, once again, we're drawing graphs, and I am not sure why my table is at the bottom. Y is equal to 3x minus 1. I'm going to write it next to here. Just based on this, firstly, is it a linear graph? Is it linear? I only have one response. 2. Yes, it is. This is a linear graph. And is it increasing or decreasing? Is it an increasing or a decreasing graph? Yo, we have conflicting answers. Let's see. It is increasing. I think increasing. It is in fact increasing because my coefficient is positive. That's a positive 3. So this is an increasing graph. Okay. Now let's get going. Y is equal to the first one, 3 times negative 2 minus 1. What's 3 times negative 2? 3 times negative 2. That is negative 6. And if I subtract 1 from that, I'm going to get A. I'll go back to the graph just now when we're drawing. A negative 7. Okay. My next one, y is equal to 3 times negative 1. And I minus 1. What's 3 times negative 1? This is negative 3 minus 1, which will give me negative 4. Nice. Next one, y is equal to 3 times 0 minus 1. What's 3 times 0? That is indeed a 0. And if I subtract 1 from 0, then my output is negative 1. Nice. Let me fill this in. Negative 7, negative 4, and negative 1. Next one, y is equal to 3 times 1 minus 1. What's 3 times 1 minus 1? It is 2. My output is 2. And the last one, 3 times 2 minus 1. What's 3 times 2? 6. And if I subtract 1 from that, then my output is 5. Beautiful. Now let us draw this. Okay. Negative 2. So if they do not write numbers here, but they're giving you numbers to guide you, right? So I have a negative 5 here. That means every single line is how much? They've given me a negative 5 over there. That means every single one of these little small lines here is how much? Are we counting in ones or twos? It's 1, guys. It'll be 1, 2, 3, 4, and 5. Well, negative 1, negative 2. So then that means negative 2 would be at negative 1, negative 2, right there. Okay. And then negative 2 goes with negative 7. So I'm going to go down. That's negative 5, negative 6, and negative 7. That's over there. Negative 1 is going to go with negative 4. So it's going to go over here. My 0 is going to go with negative 1. So that's over there. 1 is going to go with 2. And finally, 2 goes with 5. Then we draw in our line. Remember, when you are writing this or drawing this in your books or paper, you use a ruler. Okay? Much better. Okay. Actually, what we are supposed to do is, let me do this and show you the proper graph to draw here. Oop. Why did I insert that line instead of the other one? Why did I insert my new line instead of the first one that I used? What is the difference between the two lines that I just used? the arrows at the end, because why do I want the ones with the arrow at the end? It continues. My graph goes on and on and on. Okay. So if they don't tell you that your graph stops at a certain place, then you need to show these arrows at the end in case someone is confused, these ones, to show me that my graph will keep going. The same way this axis will keep going, this graph will also keep going. And you guys were correct. This is indeed linear and this is indeed increasing. Okay. All right. Negative x minus 3. Y is equal to negative x minus 3. Firstly, is this linear or not linear graph? Non-linear graph. Is this a linear or is this a non-linear graph? No, everybody's saying non-linear. Why do we say it's non-linear? Why is it non-linear? Oh, we're confusing it, guys. Being linear has to do with my exponent. Does this x have an exponent? No. So then this graph is? The graph is what? It's linear. Remember, linear only has to do with the exponents. Now I'm going to ask, is it increasing or decreasing? And this time you look in front of the x. Is it increasing or decreasing? There we go. It's a decreasing graph. Okay. Now let's find our points. First one, y is equal to, now you have to be careful here. Okay, we have to be careful. I'm actually going to erase this color to show you what I want to show you. The first negative is the one that is in my equation, okay? But then my point is also negative, so it's negative, negative 2 minus 3. So this second negative over here is the one from my input. And what are those two negatives going to do? They're going to become a positive. So this is actually going to become positive 2 minus 3. And what is positive 2 minus 3? Negative 1. Nice. Okay, next one is also a negative point. Y equals to negative 1 minus 3. Once again, these will become a positive 1 minus 3. And what is 1 minus 3? It is negative 2. Let me fill this in. Negative 1, negative 2. Next one, y is equal to 0, negative 0 minus 3. Can 0 be positive or negative? 0 is actually neither positive nor negative. It's just 0, okay? So this is actually just like saying 0 minus 3, which will give me negative 3. Next one, y is equal to negative 1 minus 3. What's negative 1 minus 3? That's negative 4. And finally, y is equal to negative 2 minus 3. And that gives us that's negative 5. Okay. Did we even need the top half of the y-axis? Do we need these numbers here? No, why? Tell me why. Why did we not even need the top part? You always have to add the positive signs instead of the number by a second. No, you don't. I just wrote that to show you where it comes from. That a negative and a negative gave us a positive. Okay, you don't have to write it. You can just write the number. Yes, all my outputs are negative, so I don't even need the top half of this. Okay, so let's start. -2 goes with -1. -1 goes with -2. 0 goes with -3. 1 goes with -4. And 4 goes with -5. You're welcome, Samulo. Whoop. And my graph, let me draw the correct graph here. Goes like so. And so. Okay,